We are going to finish our introduction on graph theory with some particular type of graphs, which are trees. Trees are graphs which are connected and they are not cyclic. So you cannot find a closed path within the graph. However, you can connect all the nodes between them. When you have several trees, you can consider that this is a forest. What you have is that each connected component is in fact a tree. And what you have below in the slide is either you can consider that you have three trees, or you can have a forest with three connected components that are trees. Whether you consider one thing or the other is indicated when it's defined what are those graphs. Another property that is characteristic of graphs is that nodes of degree 1 are called leaves, and we will see that there is a connection between the number of edges and the number of nodes that we have in the tree. So trees satisfy several properties, such as that when you have a tree of n nodes, it has exactly n minus 1 edges. Besides that, in trees there are at least two nodes of degree 1. We have at least two leaves. And given a pair of nodes in a tree, there's only a single path connecting them. The reason is that if we have two paths, we can join together these paths, and in fact we will have a cycle. Trees can be defined if we are combining several of those properties. So we can say that the following definitions are equivalent. G is a tree, G is a cycle connected graph, or G is simple and there is only one path between each pair of nodes, right? G has no cycles, it's a cyclic, and the number of edges is equal to the number of nodes minus 1. The reason is that if we have at least the same number of edges and that the same number of nodes, we will close the cycle and we will have, this is not tree. And G is connected and the number of edges is equal to the number of nodes minus 1. So we can take this second property and replace either by a cyclicity or connectivity, and we will have the other property around. So when we are considering a graph, it's interesting to consider the generating trees. Generating trees are trees that are formed by some edges of the graph, and they are connecting all the nodes of the graph. So if we have this first property, this first graph with ABC connected by edges, we have that the following trees connect the nodes of the previous graph using some of these edges. So we can have AB, AC, or we can have AC and CB, or AB and BC. In these three cases, what we have are trees. So one problem is to find some important trees when we are dealing with weighted graphs. Because when we have a graph, it's interesting also to deal with trees because they permit to connect all the nodes, as we have said. So one interesting case is when we are dealing with the development of infrastructures. Here we have, for instance, the example of the high-speed train in railways in Spain. So this is in fact a tree. When you are doing the deployment of an infrastructure that is expensive, the first thing is to deploy it and later to try to shorten the connections between some regions. And in this case, what you will do is to close cycles. So in the case that we have a weighted graph, it's interesting to find among all the trees what are the ones that are connecting the edges, which are generating trees, with higher and with lower weight. And in both cases, we can have some of them. The solution is not unique, but we can find them. And they can be solved using Kruskal's algorithm. Consider on the left that we have the initial graph, right? With the nodes 1, ABC connected with edges of weight 1, 5, 3. So we can have two particular trees. The one with highest weight is ABBC, and because if you add the weights of these edges, what you have is the total sum is 8. You can also have the tree ACCB. If you add the weights, what you will have is that the result is 4. The first one, it was the highest weight generating tree, and the other one is the minimum weight generating tree. You have in the middle one case, which is ACAB, which has weight 6. But the thing is that it's interesting in some cases to find the ones with highest weight and with lower weight. So this is all what we have to say about graphs, and in particular in this video about trees. And in the next video we are going to speak about metrics that we can define to study networks and to study graphs. That's all.